Dear students, welcome to the class. In this session, we will learn about the distinction test between primary, secondary and tertiary alcohols, interconversion of alcohols, then dehydration of primary, secondary and tertiary alcohols, and also the comparison of rates of dehydration of alcohols. Now let us discuss about the distinction test by Victor Meyer method. The Victor Meyer test is used to differentiate between the primary, secondary and tertiary alcohol by the color they form when they interact with the Victor Meyer reagent. Here in the first step, the alcohol is treated with phosphorus and iodine to give alkyl iodide. The alkyl iodide formed is distilled with silver nitrate to yield nitroalkane. The nitroalkane formed is finally treated with the nitrous acid and the solution is made alkaline. Now, the color of the resulting solution is observed for differentiating the alcohols. So, the primary alcohols, they form blood red colored solution, whereas blue color solution is formed if it is secondary alcohols, whereas tertiary alcohols do not produce any color and hence they form colorless solution. The distinction test for primary, secondary and tertiary alcohols by using oxidation method. The oxidizing agent used in this reaction is normally a solution of sodium or potassium dichromate acidified with dilute sulfuric acid. If oxidation occurs, then the orange color solution containing the dichromate ion is reduced to green solution containing chromium ions. In case of primary alcohols, they can be oxidized either to aldehydes or carboxylic acid depending on the reaction conditions. So here they form an aldehyde and then acid containing the same number of carbon atoms. In case of secondary alcohols, they are oxidized to ketones with the same number of carbon atoms. For example, if you heat secondary alcohol propane to all with sodium or potassium dichromate solution acidified with dilute sulfuric acid, propanone, a ketone is formed. Whereas for tertiary alcohols, they are not oxidized by the acidified sodium or potassium dichromate solution and there is no reaction. Here we will see how to convert primary alcohol to secondary alcohol. The example taken here is ethyl alcohol conversion to secondary butyl alcohol. So in the first step, the ethyl alcohol undergoes oxidation in presence of potassium dichromate and oxidizing agent to form acetaldehyde. And this acetaldehyde further reacts with ethyl magnesium bromide, or in other words the Grignard reagent, to form an addition product. And this undergoes hydrolysis forming butyl alcohol, which is a secondary alcohol. Okay, now we will see the conversion of secondary alcohol from tertiary alcohol. The example taken here is isopropyl alcohol conversion to tertiary butyl alcohol. In the first step, this isopropyl alcohol undergoes oxidation in presence of potassium dichromate forming acetone, and the acetone further reacts with methyl magnesium iodide forming an addition product, and this further undergoes hydrolysis forming tertiary butyl alcohol. Now we will see the conversion of primary alcohol to tertiary alcohol, or in other words the conversion of isobutyl alcohol to tertiary butyl alcohol. So in the first step, the isobutyl alcohol is heated in presence of alumina at 625 Kelvin, where the dehydration reaction takes place forming isobutene, and this isobutene reacts with hydrogen iodide forming an addition product, and this addition product in presence of silver hydroxide undergoes substitution reaction where the iodine is replaced by the OH group, forming butyl alcohol, which is a tertiary alcohol. Now let us know about the dehydration of primary, secondary and tertiary alcohols. You know that the elimination of water from a compound is known as dehydration. When alcohols are heated with sulfuric acid or phosphoric acid, they get dehydrated to form alkenes. Dehydration is done by either heating the alcohol with concentrated sulfuric acid or phosphoric acid at high temperature, or by passing the vapors of alcohol over alumina. The dehydration of alcohol requires an acid catalyst, and the reaction proceeds via the formation of a intermediate carbonium ion. While we compare the rate of dehydration of primary, secondary and tertiary alcohols, the rate determining step in the dehydration reaction is the formation of carbocation, and the ease of formation of carbocation follows the order like tertiary followed by secondary, and this is followed by primary alcohols. Hence, the dehydration of different classes of alcohol also follows the same order, where tertiary alcohol more readily undergoes dehydration, followed by secondary alcohol, and this is followed by the primary alcohol.